final example for this lesson, we're going to look at sort of a complex problem involving two right triangles kind of sandwiched next to each other. So Marla's trying to find my label was wrong there, so I just crossed it off. Marla's trying to find the height of a building. And from a given point on the ground, let's say that she's here, she can measure that the angle of elevation to the top of the building, so the building is here, and we want to know the height of it. This angle is 74.2 degrees. They're not telling us how far away from the building she is. But then she moves back 35 feet. So we know that this distance is 35. And she remeasures the angle of elevation. There are instruments that you can use to measure the angle of elevation. And now the angle of elevation is 51.8 degrees. We want to see if we can use this information to find the height of the building. And believe it or not, you actually can. So let's put some labeling here. Let's call this triangle ABC, the original triangle that was created from her first measurement. And then let's put another point here because we created a new right triangle when she stepped back. So looking at triangle ABC, which is the one on the right there, we know that the tangent of 74.2 degrees is the opposite side, h, over the adjacent side, x. I'm going to solve this for h because that's what I'm trying to find. So what I'll do is I'll multiply both sides by x to clear that fraction. And that'll give me x times the tangent of 74.2 degrees is equal to h. Okay. I've still got two variables, but I think the second triangle might help me contend with that. Let's look at the second triangle. Let's look at triangle DBC. That's the triangle that was created when she stepped backwards. Well, if we want to do the same thing that we just did by kind of looking at the tangent, I'm looking at this here, I can say that the tangent of 51.8 degrees is the opposite side, h, over the adjacent side. In this case, the adjacent side is really long. It's 35 plus x. It's that whole side combined together. I can do the same thing that I did in the first one, is solve this for h by multiplying both sides by 35 plus h, or sorry, 35 plus x cancels over here. And so I have 35 plus x multiplied by the tangent of 51.8 degrees equaling h. So I have two different things that are equal to h, so I can set those two things equal to one another. So in the first equation, I have x times the tangent of 74.2 degrees. And from the second equation, I have 35 plus x times the tangent of 51.8 degrees. Now this part, even though I'm not plugging into the calculator, it just represents a number. And when I have a number multiplied by something in parentheses, I can distribute it to both items in the parentheses. So that's what I'm going to do next. I'll have 35 multiplied by the tangent of 51.8 degrees, and then also x multiplied by the tangent of 51.8 degrees. I'm trying to, now I only have one variable right now. I only have x, and so I want to get all of the x's together so that I can solve an equation. I want to have x equals. So I need to get anything that has an x onto the same side. So I'm going to subtract this particular term because it has an x in it from both sides. Okay. So now on the left-hand side we have x times the tangent of 70.2 degrees minus x times the tangent of 51.8 degrees equaling 35 times the tangent of 51.8 degrees. I have two numbers. This is one of them. This is another one. And they both are multiplied by x. So that x can be factored out of both of them into the front. Again, if I were to multiply this back out, this would give me x times tangent, that's the first term. And then multiply this out, this would give me x by the other tangent, that's the second term. What I did is I went in reverse and I moved that x out to the front. I know this looks really complicated, but this whole thing is just a number being multiplied by another number. And because I want the x by itself, I'm going to divide both sides by the item that I'm trying to remove. So I will divide both sides by this whole complicated thing in brackets. Tangent 74.2 degrees minus tangent 51.8 degrees. Now I know you might want to plug this into the calculator and get decimal answers to make this simpler, but to avoid getting what we call rounding error, which is where when you get to the end of a problem and you're off by just a little bit, you want to try to wait until the very last step to enter things into a calculator. So this all cancels out, and I'm left with x equals this whole thing that now I will enter into the calculator. All right, I'm going to plug that into the calculator. Let's see what I get. I am getting that x is approximately 19.7 feet. I use this little squiggly line to denote approximately. Let's go back up and look at what the original problem was. The original problem was asking us to find the height, but we found this number, we found x. So let's go back to this version here and plug in what we found for x to get our final answer. I'm going to go to x times tangent 74.2 degrees equals h. Again, I'm trying to find the height of the building. We just found that x was 19.7, so we'll put that here. And we'll plug that into the calculator, and this will give us the approximate height. And for this, I'm getting about 70 feet. Right, that is definitely a level 10 out of 10 application problem, but it is one of the real applications that we use trigonometry for. All right, thanks for watching my videos, and I will see you in class on Thursday.